Howdy, this video will cover solving systems of equations. Now, systems of equations. What is it? What are they? Systems of equations is a collection of equations involving the same set of variables. So, a collection of equations. If we're doing linear equations, we have y equals mx plus b as a linear equation, but that's just one. For a system, we need more than one, so here's our second equation, y equals mx plus b, and designate this y1 and designate this y2. So that is a system of equations, because there's more than one equation. Now, what is a solution to a system of equations? Well, let's see. If we have two lines graphed on a graph, what do y'all think the solution to those two lines would be? It would be where they cross, the intersection. So, the solution is any point that lies on each line of the system simultaneously, or in other words, the intersection. Right there. So, graphing possibilities. There are three cases. Case one is where we have two distinct non-parallel lines that cross at exactly 1 point. This is called an independent system of equations. So we have two lines, and they cross at 1 point. So in other words, pretty simple, independent systems have only one solution. Case two, two distinct lines that are parallel. Since parallel lines never cross, then there can be no intersection. That is, for a system of equations that graphs as parallel lines, there can be no solution. This is called an inconsistent system of equations. So as you see here, we have two parallel lines. They never cross, they never touch. So therefore, inconsistent systems have no solutions. Okay? So when you think inconsistent, think no solution. Last case, case three, appears to show only one line, but it is actually the same line graphed twice. These two equations are the same line, therefore intersect at every point and have infinite solutions. This is called a dependent system. So when you have a dependent system, so dependent systems have infinite solutions. Now, other vocabulary you will need to know. What is an intersection? It is the point where two lines meet. And what is parallel? Two lines are parallel when they do not intersect or touch at any point. Solving by graphing. So, pretty much, let's jump right into our examples. Given two equations, solve the system of equations by graphing these two lines. Let's see, let's change the color to red. So here, we have y equals 3x minus 2. And our general equation for linear equation is y equals mx plus b, where m is your slope and b is your y-intercept. So for our red line, let's first find our y-intercept, because you need to find your y-intercept before you find your slope. And your y-intercept for this line is -2. And then your slope is going to be 3 over 1, because we're always going to have rise over run. So let's go ahead and graph our equation. So starting at the origin, our y-intercept is -2, so go down 2 from the origin. Then our slope is 3 over 1, so we're going to rise 3 and go to the right 1. Rise 3, right 1. Rise 3, right 1. Then the opposite direction, and then here is your line. Okay, so now let's go ahead and graph the other line in green. So our y-intercept for this line is going to be -6, and our slope will be -1, because there's just a variable there, so therefore the number in front of that variable was always going to be 1. And so we have -1 over 1 for rise over run. So start with your y-intercept. From your origin, go down 6. Your slope is -1 over 1, so we're going to go down 1 because it's negative, and right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1, etc. And there is your other one. Okay, other line. So the solution is going to be the intersection right here. So let's go ahead and find what that point is. It's going to be -1, -1, 2, 3, 4, 5. So our solution will be -1, -5. Last slide, solving by graphing, given two equations, solve the system of equations by graphing. So again, let's go ahead and graph these two lines. Let's graph the first one in green. We're going to have our, let's find our y-intercept first. So y-intercept will be -4, and then our slope will be 2 over 1. So from the origin, you're going to go down 4 because our y-intercept is -4. So 1, 2, 3, 4. And then our slope is +2 over 1, so we're going to rise 2 and run to the right 1. Rise 2, right 1, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. And our line is approximately right there. Okay, now let's go ahead and graph our second line in blue. And let's find our y-intercept, +1. So y-intercept is 1. Our slope is going to be -1 over 2. So let's go ahead and choose our find our y-intercept. So from our origin, go up 1. Then slope is negative, so we're going to go down 1, and then we're still going to run to the right. So right 2. Down 1, right 2. So there's our line. And the intersection point is right there. So remember, our coordinate pairs, x, y, you're always going to run first before you jump. So that point is 1, 2 to the right. So 2, we don't go up or down, so 0. 2, 0 is your solution. And that's all she wrote, guys. Thanks for watching. Don't forget to, actually, I should have reminded you before, don't forget to get your notes from the website, print it off, take your notes, and then do your assignment.